Let's see this selection sort technique. Okay, here what we do, what is the logic behind this selection sort? In bubble sort, we compare pairwise comparisons. In insertion sort, as and when the elements are being inserted, they are compared. New element is coming, they are compared. Next element, it is being compared. So we are generating a sorted set. This is a little quite different compared to those two selection sort. What happens here is that this is the array, for example, right? You will first find out the largest element. You will first find out the largest element, and once you find out the largest element, you will swap this largest element with the last location. You will swap the largest element with the last location. You can do this in two ways: by choosing the smallest element and bringing it to first place, or by choosing the largest element and taking it to last place. Both can be done. It's a small, just small condition change in the code. You can do this technique, selection sort, in two ways. One, by choosing the minimum element and then trying to bring it front. Then again go back, find the next minimum element, try to bring it front. Then again go back, next minimum element, try to bring it front. That way you can do. Or find out the largest element, take it to the back. Next, find out the largest element, take it to the back. This way also you can do it, right? So here in this case, we will try to study by taking this largest element to the end. We will see, we can run that for both the cases, right? See, I'm checking whether this element I have selected. Now I will assume this as the max, the first element itself as the max. Then I'll compare with 1 and 1 and 5. Which one is max? 5 is only the max. Then again 3 and 5. 5 remains the max. Okay. Then come to 4. 5 remains the max. Then come to 6. 6 is the maximum. Now this becomes max. Okay. Next, what I am doing? 2. No, 6 is only the max. Then this is the largest we find out. This one is swapped with the last element. This has to swap with the n minus 1th location. N minus 1 location, you have to put that. Okay, when I is 0, it is n minus 1. When I is 1, sorry. Just a second. Right. Yeah. So when this is large, we are swapping it with n. So I was talking about I equal to 0. We do it with n minus I. When I becomes 1, that is second iteration, we do it with n minus 1. We do it with n minus 2. When I is 2, we have to put that largest number into n minus 3. It is same as that, n minus 1 minus I, or n minus I minus 1, whatever you write. Now this is done. Now what you have to do? This has come its own original place. Largest one has come here. Next iteration again begin from 5. This is your max element. Compare this max element with 1. This remains. With 3. This remains. With 4. This remains. With 5. This remains max. 5 is remaining as max. This you will swap with this element. Like this you will be swapping. So 3, then 4, then 2. Yes, this is largest. Swap it like this. So just replace, exchange, swap the values. Okay, this is done now. Again begin from 2. Let this be max. 2 is max. Compare with 1, still 2 is max. Compare with 3, this becomes max now. This is gone. Now compare 3 with 4, this is again gone. This becomes your max. Okay, and when this becomes max, once this becomes max, you have to compare with which one. When you find the max element, you have to compare with this location. So here there is no change because the element is already there in this location. This is the largest, we keep it there itself, right, in that location itself. Then comes 2. So this is max now. Compare 2 with 1. Okay, so this remains. 2 with 3. When you compare 2 with 3, this becomes your max. again that is in the same location, no change, right? Then 2 and 1, yes, this is large, swap it. This way you do it in selection sort. Okay, what we are trying to do, the idea is that we are trying to push the largest element, we are trying to select the largest element. Okay, you are trying to select the largest element. If you go to the first case, we are trying to select the largest element. This largest element I am trying to push it to the end, or else you can always select the minimum element. Select the minimum element and try to push this to beginning. Okay, so if you do that logic, what will happen here? Let's try to write that sequence 5, 1, 3, 4, 6, 2. You will assume this as your minimum. Okay, then you will compare with 1. Is that minimum? Yes. Now minimum becomes 1. Then 3. 3 and 1? No. 1 remains. 4 and 1? No. 6 and 1? No. 2 and 1? No. 1 remains minimum. This 1 you will replace it with 5. So it becomes 1, 5, 3, 4, 6, 2. Okay. Now again you will focus from here. This one. You will assume this as your minimum. So minimum is 5 now. Compared to 3, 3 becomes minimum. Then 4, no. 6, no. 2, yes, 2 becomes minimum. So we will compare these two again. Swap these two again. So 2 comes here and 5 goes there. So it becomes 1, 2, 3, 4, 6, 5. That way you can keep pushing the elements towards the front if you are choosing the minimum case. And if you are choosing the largest case, you are pushing the element to the end. Okay, that is the logic of selection sort. Let's see the coding of this, how to write the code for this implementation. Just a second. Yeah, see this. I will try to explain you. You can have a different style. See, I have taken the minimum case here. Minimum, right? Minimum equal to I, that is index 0. The element at the first location, I am assuming it. Now I am repeating from j plus 1. That is the second element, right? I have to compare with this element. When you have some elements, assume this as your minimum. Okay, then compare this with the second case. See, j less than a normal. If a of j, that is this element, is less than a of min, suppose I have 13 and 5 here. What I have to do? I have to make this as my minimum. I have to make this as my minimum. So that minimum which is at 0, we are making it as 1. The index I am making it as 1. Now minimum is pointing this location now. Again just go and repeat this. J plus plus, j points to this location. Compare this with the minimum. Compare this with minimum. Whichever is minimum, that index will come here. So after repeating this procedure, you are getting the index. You are getting the index of smallest element into your min. Then when you get this, right, your I did not change. Your I did not change. It is at 0 only, right? So you are swapping the 0 with the minimum element. That is the first location with the minimum wherever it was. This is my 0. I found minimum here. That is at some location j. These two elements we will swap it like this. See, temp equal to a of min equal to a of I equal to temp. Now after this you will go and increase I value. I becomes 1 this case. Again repeat. You will take the second element as the minimum. Then third element you will compare. Starting from third element you will compare. Find out the minimum. That if you again you will swap it with the first element. So your index, your 0 means you are bringing the smallest element first place. 1 means you are bringing second element. 2, when I value is 2, you are bringing the third element. When I value is 3, you are bringing the fourth element. That way you are trying to place those elements. Why it is called a selection sort? Because we are selecting a largest number or we are selecting a smallest number. That's why it is called selection sort. Okay, you are either selecting a largest number and you are trying to push that, or you are selecting a smallest number and trying to push that. That's the reason we call it as selection sort algorithm. Okay, so these three are very popular. Can you guess the best case, average and worst case for this technique? Right, best case, worst case, and average. Any guess? Please guess the best case, average case, and the worst case. Worst is order of n square, because definitely no, we have to repeat everything this and this also every time. If you observe, the best case here in selection sort, what is the best case? I'll just go to this example. This is me, this is the actual input. Assume this is the best case, right? What I am trying to do, if I am following minimum logic, what I am trying to do, I am assuming this as my minimum. Okay, you will start iterating from here. Compare this with this. Is this minimum or this minimum? This is the minimum. Compare this with this. Is this minimum or not? This is the minimum. Compare this with this. Yes, this is the minimum. Compare this with this. Yes, this is the minimum. Compare this with this. This is the minimum. I have iterated it n times. That is n elements are there. N elements I have verified. And when this is the minimum, I have to swap this with the same location. Iteration is over. Now, what is the second iteration? Assume shift that minimum to here. This part is over now. We are taking 2 as our minimum now. And you are beginning from 3 again. Compare 3 and 2, this is minimum. Compare 4 and 2, this is minimum. 5 and 2, this is minimum. 6 and 2, this is minimum. Though it is sorted order, again still I am repeating it n number of times. That's the reason the best case is also order of n square. Average is default n square because worst is n square. So in all three cases, best, average, and worst case for selection sort, it is order of n square. I hope you understood. Even though it is in sorted order, we are trying to find out the minimum always, comparing with second, third, fourth, fifth. Again place it. Again take the second element, compare with second, third, fourth, fifth. So we are repeating this always, right? So that's the reason for this, it is order of n square in all three cases, right? Only for insertion sort, the best case is order of n. Remaining all for bubble sort, for insertion, for selection, if you talk about best case, average case, and worst case, all are n square here. Here also n square, n square, n square, n square, n square, and this is n. Okay, very important point. Please remember this. So this is about the selection sort technique, which is very important and powerful.